In this video, I'm going to go through the solutions to limits worksheet. The first one is given the graph of the function. Evaluate the following. If a limit does not exist, you must state a reason. The first one says when x goes to 2 from the right, two is here. We go from the right. It is obvious that when we get closer to 2, the value of the function becomes 3. The next one says when x, the limit of function when x goes to 2. From the right, we said that the value of the function is 3. From the left, meaning if I go this way, the value of the function is again 3. So the left is equal to the right, so the function, the limit at x equal to 2, going to 2 is equal to 3. The value of the function at 2, since at 2 this is a hole and this is the point, the value of the function is 2, 4, 6, 7. And since the left and right limits are not equal to the value of the function, you can see that there is a discontinuity here. And the discontinuity is going to be a removable one because left and right limits are equal. The value of the function now at -5. -5 is here. So the value of the function is here, which is -3. Now the value of the limit when x goes to 8 from left. 8 is here, going from left, meaning it goes from here. So the value of the function becomes -2. The next one is the limit when x goes to 8 of f of x. If you look here, this is 8. When x goes from the left, we said that it's -2. But when it goes from the right, the function at 8 has to follow this one, since the limit going from the right goes to 3 and it's not equal to the limit going from left, then it means that there is no limit here, so not available. The next one is the limit of x going toward -13 from left. -13 is here. Going from left, meaning we are going this way, so the value of the limit is -infinity. The value of the function at f of -13, you can see when we go to -13 from left, we get to -infinity, but if we go from the right, we get to +infinity, so there is no value for f of -13. Now identify where f of x is continuous and whether it is removable, jump, or infinite discontinuity. We can see that at x equal to -13, here the function is infinite, so we say x equal to -13 is infinite discontinuity. The next one is at this point, you can see that the left and right limits of the function exist at x equal to 2 and they are equal to this value. So this is a removable one. So we say x is equal to 2 is removable. At x is equal to 8, which is here, you can see that the right limit, which is going this way, is equal to 3. and the left limit, which is this one, is equal to -2. Since they are not equal, this is a jump discontinuity. So at x equal to 8 is a jump discontinuity. The next one is to evaluate the following limits. I'm going to write the first one, limit of x goes to -3 of x plus 3. The denominator, I'm going to try to factor it out. I'm looking for two numbers with the product of -27 and the sum of -6. Those two numbers are -9 and 3, so I can write this one as x minus 9, x plus 3. I can factor x plus 3 out, so I get limit of x going to -3 of 1 over x minus 9. And if I evaluate this one, -3 minus 9 is -12, so the answer is -1 over 12. The next one is limit of h goes to 0 of square root of 25 plus h minus 5 over h. If h goes to 0, you get 25 square root, which is 5 minus 5 is 0 over 0. So to cancel this 0 over 0, I'm going to multiply the numerator by the conjugate of the numerator. So I'm going to get limit of h goes to 0 of square root of 25 plus h minus 5 times square root of 25 plus h plus 5 over h times square root of 25 plus h plus 5. Now the numerator, I can use the fact a minus b times a plus b is a squared minus b squared, and I can write this one as limit h goes to 0 of 25 plus h square root square is 25 plus h minus 25, 5 squared is 25 over h times square root of 25 plus h plus 5. 25 cancels with 25, then the h in the numerator cancels with the h in the denominator. I get limit of h goes to 0 of 1 over square root of 25 plus h plus 5. When h goes to 0, this becomes 1 over square root of 25 is 5, 5 plus 5 is 10. So this is equal to 1 over 10. The next question says that if the function f of x is given by 2x when x is between -infinity and -1, x squared when x between -1 and 2, 0.5x plus 3 when x is between 2 and positive infinity, first determine if and where the function is continuous. If it is, then explain why. We look at the extreme points here. The first one is -1. If the limit of f when x goes to -1 from the left, we have to use this equation. This means that the limit becomes -2. The limit of f when x goes to -1 from the right, we have to use this formula. Then limit becomes +1. -1 squared is +1. You can see that -2 and 1 are not the same, so the function is discontinuous here. Now, so this is the first one. And you can see that this is a jump discontinuity because the left and right limits are not equal. The second extreme point is 2. The limit of the function when x goes to 2 from left, we have to use this formula. And 2 squared becomes 4. The limit of function when x goes to 2 plus from right, we have to use this formula. Now 2 times 0.1 is 1, 1 plus 3 is 4. And you can see that the limits exist, so the function is not discontinuous at 2. Now we have to find the limit of the function f of x when x goes to 2 from left. When x goes to 2 from left, we have to evaluate this function. So when x goes to 2 from left, it becomes 2 squared, which is 4. Now when the function goes to 2 toward 2 from the right, we have to use this function. This means 0.5 times 2 is 1 plus 3 is 4. If you check I and II, these two limits, you can see that both of them are equal to 4. Now, the limit of the function when x goes to 2 is going to be using this formula, because here it says x is equal to 2 in the limit. So 2 times 0.1 again is 1 plus 3 is 4. Now the value of the limit when x goes to negative 1 from left, we have to use this formula. Negative 1 times 2 is negative 2. Now we have to find the value of the function when x goes to negative 1 from right. So we have to use this formula, and it becomes 1. Since the limits are not equal from left and right when x goes to negative 1, this limit does not exist. Now we have to find the following limits. Limit of x goes to 3 of x squared plus 2 over x minus 2. Remember, the first step of every limit is just to substitute the limit and see if we get a valid result. If we do, then that's the limit of the function. For a, if I substitute x equal to 3, I get 9 plus 2 over 3 minus 2, which is 11 over 1, which is 11. So this means that the limit of a is 11. For b, if I substitute 0, I get 0 squared, 0 minus 0 divided by 0 is 0 over 0. So this means I have to simplify it. So if I simplify it by factoring x from the numerator, I get x minus 2 over x. X cancels with x. So the limit becomes negative 2. The next one is a limit of 125 minus x over x to the power of 1 over 3 minus 5. To do this one, I'm going to let y to be x to the power of 1 over 3 minus 5. From here, I get that x to the power of 1 over 3 is y plus 5. I'm going to cube both sides, so I get x is equal to y plus 5 cubed. Now, in our limit, x goes to 125. If x goes to 125, then it means that from here, I can say y is 125 exponent 1 over 3 minus 5, which is 125 cube root is 5 minus 5, which is 0. So this means limit of x goes to 125 is the same as limit of y goes to 0 for function in terms of y. So this expression becomes limit of y goes to 0, but 125 minus x is this one, so I can write 125 minus y plus 5 exponent 3 over, and this one we substitute to be equal to y. Now I'm going to use Pascal's triangle to expand y plus 5 cubed. So to do this one, I'm going to write 125 minus, to expand y plus 5 cubed. Remember the Pascal's triangle is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. This row is row 3, which we have to use. Now I'm going to expand this one as y cubed, 5 exponent 0, y2, 5 exponent 1, y1, 5 exponent 2, and y0, 5 exponent 3. Now I'm going to use these coefficients. I put it on the left of each term. So this is 1, then it's going to be plus 3, then it's going to be plus 3, then it's going to be plus again 1. Now I'm going to simplify it. This becomes 5 exponent 0 is 1, so 5 cubed. Now 3 times 5 gives me 15, so plus 15y squared. Then 5 squared is 25 times 3 is 75, so plus 75y, and 5 cubed is 125, y exponent 0 is 1, so I get plus 125 divided by y, which is the same as, now if I distribute negative inside the bracket, 125 and negative 125, they're going to cancel, so I'm going to end up with negative y cubed, negative 15y squared, negative 75y over y, and remember this is limit when y goes to 0. Limit y goes to 0. Now if you look at the numerator and denominator, I can cancel y, so this y, this becomes 1 and this becomes 2. So I get equal to limit y goes to 0 of negative y squared, negative 15y, negative 75. When y goes to 0, this becomes 0, this becomes 0, so the answer is going to be negative 75. The next one is the limit of x goes to 1 of 3 minus square root of 8 plus x over 1 minus x. Remember, when you're dealing with square root, the way to get rid of the square root is to use the conjugate. But before we do that, we just want to check to see if just substituting x equal to 1 are going to make it make the denominator 0. If x is 1, then you get 3 minus square root of 8 plus 1 is 9. So you get square root of 9 is 3, 3 minus 3 is 0, divided by 1 minus 1 is 0. So it's 0 over 0. So I'm going to multiply the numerator and denominator by conjugate of 3 minus 8 plus 8, x. So I get L when x goes to 1 of 3 minus square root of 8 plus x times 3 plus square root of 8 plus x divided by 1 minus x times 3 plus square root of 8 plus x. Now the numerator is a minus b times a plus b, which is a squared minus b squared, so I can write this one as the limit of x is 1. 3 squared is 9 minus square root of 8 plus x squared is 8 plus x, so I get negative 8 minus x over 1 minus x times 3 plus square root of 8 plus x. Now 9 minus 8 is 1, so 1 minus x in the numerator and 1 minus x in the denominator, they cancel. So I'm going to get limit of x over going to 1 of 1 over 3 plus square root of 8 plus x. Now, when x goes to 1, 8 plus x becomes 9. Square root of 9 is 3. 3 plus 3 is 6, so this really becomes 1 over 6. The next question says, consider the function f of x, x squared if x less than or equal to 0, 1 plus x if x is greater than 0. Does limit f of x exist when x goes to 0, and explain. When x goes to 0, we have to consider two from left and right limits. So we say that limit of x going to 0 from left is equal to, since going from left we have to use this part of the function, we get 0 squared, which is 0. When x goes to 0 plus, I have to use this equation. So the limit of function f becomes 1 plus 0, which is 1. You can see that these two limits are not equal, so this means that the function is discontinuous, and since left and right are not equal, this means that this is a jump discontinuity. The next question says, find the values of a and b that make the function discontinuous. To solve this problem, I'm going to solve the problem of finding a and b that makes the function continuous first. So I'm going to say, to be continuous, the extreme points are negative 1. So I'm going to say, what is the limit of the function when x goes to negative 1 from left? When x goes to negative 1 from left, I have to use this function. So this means that the limit is a minus 1 squared, which is a minus 1. Now the limit of the function when x goes to negative 1 from right, I have to use this function. This means that it's minus 1 minus b. And the value of the function at negative 1, I have to use this function, which means a minus 1 squared, which is a minus 1. For a function to be continuous at a point, the left limit must be equal to the right limit, must be equal to the value of the function. The value of the function and the left limit, they are the same. So this doesn't really help us. But the value of the function, when it goes from left and right, they have to be equal. So this means for f of x to be continuous, a minus b has to be equal to minus 1 minus b. Minus 1 cancels out, so a is minus b. This means that for the function to be continuous, a has to be the opposite sign of b. So for the function to be discontinuous, I'm going to say a cannot be equal to minus b. This means, for instance, let's say a to be 1, b is any value except minus 1. Let's say b is 1. These two values makes the function discontinuous. The next question says that f of x is equal to x plus 1 squared minus 3 if x is less than or equal to 1, negative 2x plus 3 if x is between 4 and 1, and negative 4 if x is greater than 4. The first question is to graph the function. To graph the function, I have to graph each section of the function. So this is going to be my x, this is going to be my y. First, the easy one, it says that f of x is negative 4 for x greater than or equal to 4. So 1, 2, 3, 4. 2, 3, 4. So for x greater than 4 but not including 4, the function is negative 4. So there is a hole here, and this is my function. The next one is between 1 and 4. 4 is also included. You have to plot negative 2x plus 3. Looking at negative 2x plus 3, first of all, it's a linear function. The y-intercept is 3. So this is 1, 2, 3. The y-intercept is going to be 3. But the function is between 1 and 4. So between 1 and 4 here. So we're just going to plot the points here. If x is equal to 1, then the function is negative 2 times 1, which is negative 2 plus 3 is going to be 1. But remember, 1 is not included, so there is going to be a hole here. And then when x is 4, the function becomes negative 2 times 4 is negative 8 plus 3 is negative 5. Negative 4 is here, so negative 5 is here. But since the function is defined at 4, so this means negative 5 is also included. So the function is going to be a point here, and then we just connect them together. So this is my line here, the second one. The third one is a quadratic. Looking at the quadratic, we can see that the vertex is as negative 1 and negative 3. So negative 1 and negative 3 is going to be this point. At x equal to 1, because the function is defined at 1, you can see that 1 plus 1 is 2, 2 squared is 4, 4 minus 3 is 1. So x is equal to 1. So this means that this point is also a dotted line. To find the y-intercept when x is equal to 0, 1 squared minus 1 is 1 minus 3 is minus 2. So this is the y-intercept. So our graph becomes something like this. So this is our graph of the function. Now it says evaluate the following. The value of f of x, the limit when x goes to 1. When x goes to 1, from the left, I have to use this function. So the value of the function, 1 plus 1 is 2 squared, 4 minus 3 is 1. So the left limit is equal to 1. And the right limit, when x goes to 1, I have to use this function, becomes negative 2 plus 3, which becomes 1. Since the left and right are equal, so the value of the function when x goes to 1 is 1. And you can see from even the graph here, from left and from the right, the function is going to go to 1. When x goes to 4, again, the left limit, I have to use this formula. So negative 2 times 4 is negative 8 plus 3. Negative 8 plus 3 is negative 5. And the right one, if the function goes to 4, I have to use this formula. And the right one becomes negative 4. And you can see that these two are not equal, so we can say the limit does not exist. Now, if we go back to our graph, you can see at x equal to 4, we have a jump discontinuity because left and right limits are not equal. The next one, it says that the limit of f prime of x when x goes to -1. When x goes to -1, which is here, you can see that the tangent to the quadratic is going to be parallel to x-axis, so the rate of change is equal to 0. The last part of the question says, for what value or values of x is the graph of f of x discontinuous? If you look at the graph, the only one which is discontinuous at this point, and since the limit, the left and right limits at x equal to 4, they are not equal, this is an example of jump discontinuity. So the answer is jump discontinuity.